In this video, we are going to analyze an amplitude modulated wave or AM wave. The instantaneous voltage of a carrier wave can be represented by EC is equal to the amplitude of the carrier wave into cos omega ct. This is the instantaneous voltage of the carrier wave. So any wave can be represented by, suppose you have a wave y is equal to a cos omega t. Then this is the instantaneous value of the displacement, and a represents here the amplitude of the wave, omega represents the angular frequency. So just like that, in this equation, EC is the instantaneous voltage value of the carrier wave. This capital EC represents the amplitude of the carrier wave, and omega c is the angular frequency of the carrier wave, Okay, then I can represent the instantaneous voltages of the audio signal. So for audio signal, similar to above equation, I can represent the instantaneous voltage of the audio signal ES will be equal to amplitude of the audio signal into cos omega angular frequency of the audio signal into time. So here ES represents the amplitude of the audio signal, and this small es is the instantaneous voltage value of the audio signal. Omega s is the angular frequency of audio signal. This omega c will be equal to 2 pi fc, where fc represents the frequency of carrier signal. Similarly, this omega s will be equal to 2 pi fs, where fs represents the frequency of the audio signal. Now, the modulation factor M is defined as modulation factor M. The modulation factor M is defined as the signal amplitude by carrier amplitude. Signal amplitude by carrier amplitude. So this will be equal to the signal amplitude is ES and carrier amplitude is capital EC. So from here we have the signal amplitude ES is equal to M times EC. So I can substitute for this ES here, this equation. Therefore, the instantaneous voltages of the signal, small es can be represented as M times EC cos omega s t. So our results are the instantaneous value of the carrier wave EC is equal to amplitude into cos omega ct, and instantaneous value of the signal ES is equal to M times EC cos omega st. Now, in amplitude modulation, the amplitude of the carrier wave varies at signal frequency, and the value of the instantaneous value of the amplitude modulated wave will be equal to the amplitude of that wave into cos omega ct. The frequency of the amplitude modulated wave will be carrier frequency, whereas the amplitude varies with respect to the amplitude or intensity of the signal. Okay, so this amplitude can be written as, this amplitude will be equal to the instantaneous value of the instantaneous value of the signal voltage plus the carrier amplitude. This will be the amplitude of the amplitude modulated wave. So this is the amplitude of AM wave. Now this ES, you can substitute for ES, and if you do that, this will be equal to EC plus MEC cos omega ST. Okay, so I can rewrite this E as the amplitude of the amplitude modulated wave. E is equal to EC plus MEC cos omega ST into this term, cos omega CT. So I have substitute EC plus MEC here for this amplitude, then this cos omega CT term. Okay, now we can expand this term. The first will be EC into cos omega CT plus MEC into cos omega CT into cos omega ST. Now this form is a cos A cos B form. So we have an equation cos A cos B is equal to cos A plus B. So here you have a 2 cos A cos B is equal to cos A plus B plus cos A minus B. So I will be using this equation for these two terms. So for these two, okay. So we can rewrite this term as equal to, first term will be EC cos omega CT, then this cos A cos B E2 ഇവിടേക്ക് വരുമ്പോൾ 1/2 ഫോമുല ആവും. So you will have 1/2 into MEC cos omega C plus cos omega S T plus MEC by 2 cos omega C minus cos omega S T. Okay, so this is the instantaneous voltage of an amplitude modulated wave. Now if we analyze this wave, we can find that here we have an amplitude EC amplitude, another one is 1/2 MEC, another amplitude is ME again 1/2 MEC, and we have three frequencies. First one is omega C. This is the angular frequency of carrier wave, and another component is omega C plus omega S, and another component is omega C minus omega S. Now the corresponding frequencies will be FC, and from here you will have FC plus Fs, and this term will be FC minus Fs. So along with the carrier frequency, you have a carrier frequency FC plus signal frequency Fs term, and a carrier frequency FC minus signal frequency Fs term. Now these two terms are said to be, FC plus Fs and FC minus Fs are said to be sideband frequencies. Sideband frequencies. Here this is said to be the upper sideband frequency, and this FC minus Fs is lower sideband frequency. Okay, so the important result is in the amplitude modulated wave is equivalent to summation of three sinusoidal waves. First one is cos omega CT, another one is cos omega plus omega ST, another term is cos omega C minus cos omega ST. Second one, now we have three frequencies. Along with carrier frequency, we have FC. Along with this carrier frequency FC, we have FC plus Fs and FC minus Fs. And the third point is, this term is said to be upper sideband frequency FC plus Fs, and the FC minus Fs term is said to be lower sideband frequency. Okay, now let us analyze this upper and lower sideband frequencies. So if I plot a graph between the instantaneous voltage E versus the frequency versus instantaneous voltage, then you have a component FC minus Fs, another component is FC, and third one is FC plus Fs, now the amplitude of FC term will be equal to EC, and the amplitude of FC minus Fs will be equal to MEC by 2. So that term നമുക്ക് കിട്ടിയത് ഇവിടെ നമ്മുടെ തിയറി എന്നാണ്. ഫസ്റ്റ് ആംപ്ലിറ്റ്യൂഡ് EC, second one is MEC by 2, and third one is also MEC by 2. Okay, so these രണ്ടും ഒരേ same similar amplitudes ആയിരിക്കും, MEC by 2, and another amplitude is EC. Okay, then the bandwidth of the AM wave will be equal to FC plus Fs minus FC minus Fs, that is from here to here, and that will be equal to, so this will be plus sign, so this FC will cancel, so you will have 2 times Fs. So the bandwidth in case of amplitude modulated waves will be 2 times Fs, that is the width from this this lower sideband to upper sideband. This width will be 2 times Fs. So the bandwidth of an amplitude modulated wave is twice the signal frequency. Okay, let us consider a case. Suppose 4000 kilohertz is the frequency of the carrier wave, and frequency of the signal is equal to 1 kilohertz. Our audio signal frequency is 1 kilohertz. Then the upper sideband frequency will be FC plus Fs, that will be equal to 401 kilohertz, and the lower sideband frequency FC minus Fs will be equal to 309 kilohertz, and the difference 2 times Fs, which is the bandwidth, that will be equal to 2 kilohertz. And we are interested in this upper sideband frequency and lower sideband frequency because the signal is contained in these sidebands. Carrier wave FC നമ്മൾ സിഗ്നൽ ഇല്ല, നമ്മുടെ ഇൻട്രസ്റ്റ് ഒരു സിഗ്നൽ ബ്രോഡ്കാസ്റ്റ് ചെയ്യാനാണ്, and that signal is contained in the sidebands, so we are much concerned about the sidebands. So that's about the analysis of